Hello everyone, my name is Faraj Altumi. I'm a PhD student from Mechanical Engineering at University of Birmingham. Today we'll be present our work, which is designing a model predictive controller for pick and haul disassembly using piece algorithm. Um, Outlines of this presentation is autonomous remanufacturing, robot disassembly using model predictive control for instruction of big from whole, employing the piece algorithm to enhance the optimization of the model predictive control method. Remanufacturing is the process of making the products the same as or better than brand new. It has 6 steps to uh, process the end of life product to be ready to use. So our work, it is a first step disassembly, cleaning, inspection, repair, replace, reassembly, testing. Our work focusing in the disassembly part. So autonomous remanufacturing could be use fully autonomous disassembly and human robot collaboration. Human robot collaboration could provide more accuracy and flexibility to deal with the unpredictability and uncertainties. Uh, Fully autonomous disassembly operation are unable to address the variance related with end-of-life products, uncertainty, and complex disassembly. To reduce the uncertainty of the fully autonomous disassembly, we are researching on control system for robotic disassembly. Our focusing control system in model predictive control using piece algorithm to solve jamming and wedging problem uh, in pick and haul disassembly. Robot disassembly is process of taking apart component of the end-of-life products or waste material using robots. This process presents several challenges. Some of this some of the main challenges in robotic disassembly, unscrewing and flexible object manipulation, soft object handling, sequence planning, and pick and haul. Pick and haul disassembly problem is jamming and wedging. Jamming is condition in which the pig is not able to move due to improperly applied force and moment, and wedging is the condition in which the pig is stuck in the position despite higher instruction force. Those problems occur during the two-point contact state in pick and haul assembly as well as disassembly. Typically, pick and haul disassembly process have uh, four states uh, uh, could happen, which is no contact state, 1-point contact state, 2-point contact state, and line contact state. Reducing 2-point contact state region and controlling the position can be avoiding jamming or wedging issue. Model predictive control is an advanced method of process control that use control to process while satisfying a set of constraints. Also, the method has feedback control strategy that optimize future performance of the system to predicting the system behavior based on the mathematical model. This predicted model capture the relationship between system input and output and provide the representation of the system dynamic. The main advantage of MPC is the fact that allowed the current time slot to be optimized while keeping future time slot in the account. This achieved by optimizing fit time horizon, but only implement the current slot and optimize again repeatedly, where the control input are adjusted at each step based on the most recent system measurement and predictions. We using cost function formula, including output reference tracking, manipulated variable tracking, and manipulated variable smoothing and constraint. Using MPC for pick and hold case because it can handling multi-variable control problem with instructions between input and output. Also, it can perform online computations quickly and depth to structural changes. So the system can update a new data of pig's position based on current state by system feedback. That will help reduce the small literal error. This is force measurement recording during pick and hole unplugging process include fz and fy and fx. We make it as a reference, so as this result show MPC match the reference, which is fx, as well as minimize const function. Also, this is matching with fy and fz. This algorithm can enhance the optimized process with MPC by efficiently and exploring the solution space, potentially leading to improve control performance of faster convergence to optimal solution. MPC with this algorithm can achieve better performance in the term of the control objective, such as tracking, accuracy, stability, or energy efficiency. Using this algorithm because it has higher computations speed and short convergence time. So This is our design include piece algorithm with MPC can improve robustness against uncertainties by continuously optimize control action based on updated prediction and system measurement. Also, piece algorithm its ability to perform global research can be help MPC in finding optimal or near optimal control sequence, especially in complex higher dimensional control problem. In conclusion, integrated MPC with piece algorithm proves to be instrumental enhancing the pick and hold disassembly process by effectively addressing nonlinear and uncertainties. This innovative approach not only reducing jamming and wedging issue, but also ensuring the higher level system monitoring and advanced control performance. In future work will be apply the system for a different or for other complex robot disassembly application also will be support in general in the field. Thank you for listening. Any question, I'm happy to answer it. Please contact me by email. Thank you.